Hello grade 9s, this is Mr. Miller and welcome to lesson 6.2 on interpreting graphs. So in the first example we have a graph comparing how distance changes over time and initially at 1 hour we have a distance of looks like about 75 kilometers, and as time goes on the distance increases. Now we want to answer some questions relating to this graph. First question is, what is the appropriate value of d when t is equal to 3? So in order to do that, we are going to go to t equals 3, which is right here, and we're going to go up on this vertical line until we get to our graph. Now we're going to move across horizontally to the distance axis and figure out what is that d value that corresponds to t equals 3. And if I have to estimate this, I would say that this is approximately 270 kilometers. I start at t equals 3 on the time axis, and go vertically up to the line. And of course I make a mark there. From there, move left to the distance axis, and find the d value. So that's the method that I used here. Next, and just so I don't confuse what I did in the first part here, that t equals 3 with what I'm going to do next, I'm going to switch colors. So why don't I switch to orange, should be nice and bright and visible. I'd like to know what is the approximate value of t when d is equal to 300. So when d is equal to 300, there it is, d equals 300. Need to move along to the graph. I can make a mark there. And then I can drop down to the time axis and figure out what that time is. And it looks like it's somewhere between 3 and 4, and I'm estimating it's about 3.3. So it's approximately 3.3 hours. Next question, and we have a new graph now. We have a graph that starts off at x equals -2 and y equals 1, and goes up to x equals 3 and y equals 13. And is a straight line going from bottom left up to top right. We have a few questions associated with this graph. First question, what is the approximate value of y when x is equal to -1.5? And so when x is equal to -1.5, that's right here. Here's -1.5 on the x-axis. So I can go up to the line and make a mark. And now I can slide across to the y-axis and I'm estimating that to be at about y equals 2.3. Because here we have 2, here we have 4, this is 3, this is somewhere in between. Looks like it's a little bit closer to 2 than it is to 3, so about 2.3. So now again I'm going to switch colors for my second point that I'm going to find here. When y is equal to 10, we'd like to know what is the approximate x value that corresponds to that. So for y equals 10 here, if I move across to the line and make a mark, and then I drop down to the x-axis and find the corresponding x value, it appears to be at about 1.75. And I say 1.75 here because here we have 1, here we have 2, this looks like 1.5, and this looks like about halfway in between, so that would be 1.75. Now, I'm going to do one more example, and then I'm going to talk about all three of these just for a second and just get some terminology out to you so that you're aware of this. So in number 3, it's looking for what is the approximate value of y when x is equal to 3.5. So when x is equal to 3.5 on the x-axis, here's 3, here's 3.5. So I can go down to this point, make a mark, and then move across to the y-axis, and it's pretty darn close to -1. But I'm going to say it's close, it's at -0.9. So now the other point here, the approximate value of x when y is equal to 0.5. So here is y equals 0.5. It's right here, so halfway between 0 and where 1 would be. So if I move over to the graph, and make a mark here, and then drop down to our x-axis, it looks to me like an x value of -3 is what we're looking at. So now, just to add a little bit of terminology here for all of these values that we've found in numbers 1 to 3. Okay. So in finding those points in number 1, 2, and 3, the new points found between other points on the graph are called interpolated points. So moving on to the next example, it says here that in the deli section of a grocery store, Greek salads cost $1.50 per 100 grams. We want to plot this data on a graph. So we're actually given a table of values here, and we want to know what this graph would look like. So first of all, as far as graphing is concerned, and I know that some people get confused sometimes on whether to put the mass on the horizontal axis or the vertical axis. And to help you with that, first of all, the textbook makes it really easy. The first variable that's stated, so whether it's the top row, if they're doing rows, the top variable is always what goes on the horizontal axis. the second variable that's stated in the second row is what goes on the vertical axis. I know the textbook always works that way. If they happen to have a table of values that is arranged the other way, so if they happen to put mass and cost in sort of what people tend to call a T table this way, then the mass was intended to go on the horizontal axis and the cost was supposed to go on the vertical axis. That's typically how the textbook does organizes the work. But sometimes you may find that data is given to you backwards. And just to help clarify things in your mind, you should ask yourself this question. Does the cost depend on the mass of the Greek salad that you buy? Or does the mass of the Greek salad you buy depend on cost? Generally speaking, we calculate cost from the mass that you order. So since cost depends on mass, cost is the dependent variable and it goes on the vertical axis. The mass of Greek salad is the independent variable that goes on the horizontal axis or the x-axis. So that's just to help you determine where to put what variable. So now let's draw the axes. So I'm going to put the mass axis here, and I'm going to put the cost axis here, and I'm going to label them both. This is mass in grams, and this is cost in dollars. And we're starting at 0, 0, and we're moving up here to $1.50, and then $3, and then $4.50, and so on. On the mass axis, we're going to have, we're starting at 0, and then we're going to 100 grams. And then 200, and then 300, and 400, and 500, 600, and I think we'll need to go up to about 700, 800, there. Alright, so now that the axes are set up, we can start to put the points as they're specified here onto this grid. So the first point is at m equals 100 and c equals 150. So 100 and $1.50. Next we have 200, $3, 300, $4.50, and you can see that I've set the grid up so it's very easy to put points on here. I should mention the fact that you won't always be able to set your grid up in this way. Oops, actually that's not a point that's given to us, right? It stops at 500, 750. You're not always going to be able to set up your grid in this way. It just so happens that this relationship lends itself well to doing that. In any case, what we want to do now is we want to do a straight line that goes through all of these points. So obviously that would be this one. And you notice that I started off from 0, 0. And that makes sense because with a mass of 0 grams of Greek salad bought, you should be paying nothing for it. And, you know, does it make sense to fill in these points in between? Is it possible for you to buy a Greek salad that weighs 350 grams? Absolutely. It doesn't have to be just 300 or 400. It could be any of those points in between. Is it possible to buy a Greek salad that's more than 500 grams? Absolutely. So that's why we can extend this line beyond. So definitely this line it's a line of best fit. It's going through all these points, and it's perfectly reasonable for us to have that line on there. So with every graph that you do, it's a good idea to put a title. So if you're stuck for a title, you can simply do whatever the variable on the vertical axis is versus whatever is on the horizontal axis. So cost versus mass of Greek salad. And that's good enough as a title. It's a good idea to put a title on your graphs. Generally speaking, when I'm marking graphs, I look for things like that. Have you put the title on? Have you labeled the horizontal axis and the vertical axis? If you've labeled both axes, then I can give you full marks. I'm not just looking at the points here. I'm not just looking at the numbers, but I also want to see that it's well labeled. Now, you might wonder why I've gone up to 700 and 800 and I've extended this line that far. It's because I sort of glanced ahead and I could see that in this graph we're looking to use that graph to determine the cost of 800 grams of Greek salad. So you do need to make sure that you have room to go up that far. Okay, and likewise we also want to be able to figure out how much salad we can get for $10.50. So you know that you need to go at least that high to be able to figure that out. In any case, so let's figure out those values. So maybe I will just switch pen color here so that I can set this work apart a little bit. If we want to get 800 grams of Greek salad, so here's 800 grams. If you go up to the line and you make a mark, well, this is a pretty easy one to figure out because it's right on a grid point. And so you can see that that's going to cost $12. And then, let's see, I need to pick another color. How about pink? Let's see, lovely color. If we have $10.50 to spend on Greek salad, then here's $10.50. If we go across, make a mark on the graph, go down to the mass axis, you can figure out it's 700 grams of Greek salad would be able to buy for that price. Now you'll notice something a little bit different here compared to what we were doing before. These 2 points that we got here were points that were beyond the set of points that we plotted initially. And we had to get these points by extending the line beyond those set of points. So that means that these points are not interpolated points, but rather they are called extrapolated points. So you should write that down, that these are extrapolated points, different from interpolated points, which would be between 2 points that you already had on the graph. So now let's move on to number 5. And for number 5, we've got a car rental company that is charging a flat rate of $35 plus 45 cents per kilometer for renting a car. The graph here, right here, shows the cost of renting a car based on the number of kilometers driven. So the first question being asked with this is whether it's reasonable to do interpolation or extrapolation on this graph, yes or no. So let's think about this here. If you are renting a car, are you only going to drive at 0 kilometers? Well, I mean, first of all, nobody's going to drive at 0 kilometers. You could drive 50 or 100 or 150. Yes, that's true. But is it possible that you're going to take the car for a drive and you're going to go, say, 120 kilometers, 135 kilometers, 201 kilometers? It's not necessarily going to be exactly these points that are specified. It could be any of the distances in between. And so as a result, you're not necessarily going to be paying exactly the prices that are specified on these points. It could be any of the costs in between as well. rounded off to the nearest cent, of course. But yes, it is reasonable to do both interpolation and extrapolation. So my explanation here is going to go something like this. It is reasonable to drive distances in between or beyond those specified on the points on the graph. So now part B, it's asking what is the car rental after driving 300 kilometers? So after driving 300 kilometers, so 50, 100, 150, 200, 250, and 300 is right at the edge of the graph here. So you can see that this is going to be an extrapolated point. I need to continue this line a little bit further. So let's see if I can, first of all, just sort of match that color. It's sort of a gray color, and I guess I'm not going to be doing that with just, I should get my sort of ruler here to do this properly. Let me get a color that would match. So sort of a gray color. All right, so I'd like to extend this line way past. Okay, and let me just make sure that this is well lined up. Okay. And just so you know that this is my line that I've added, maybe I could just make this line a dashed line to distinguish it from the line that was initially given to us. Okay, so I've extended that a little bit. Anyways, so going at d equals 300 and going straight up and finding the point on the line and then moving across here right there. Looks like this is a cost of, so what have we got here? We've got 120, 150, so this is a gap of 30. In between here it's $15, so this is 165. That would be 180. So this might be about halfway in between, you know, maybe something like $173. So, and I'm getting that from a graphical technique. I realized that what I could do is I could say, well, I know that it's going to be, you know, $35, right, plus 45 cents per kilometer. So 35 plus 0.45 times 300 gives me exactly 170. 173, which I got from this graphical method, is pretty darn close to that. And so finally here we want to know how many kilometers can be driven for a rental cost of $115. So here's 90, here is 120, this would be 105 here. That's not what we're looking for. We want to go to 115. So it's approximately at this location. We want to go across, make a mark, and then drop down here and figure out what is this value for distance. So here's 150, here's 200, this would be 175, so I'm guessing this is about 180 kilometers. And so again, you may have a slightly different value based on what you've estimated, but that's okay. Just to relate back to the terminology that I mentioned about interpolation and extrapolation, so this point, because we were going beyond the set of points that we had here, we had to extend the line. This is an extrapolated value that we found, whereas this 180 kilometers, it was found at a point in between 2 points that we already knew, so that is interpolated to get that value. Alright, so that is the end of lesson 6.2 on interpreting graphs. Thanks for watching this video and have a great day.